Okay, so now the next question on 8.1.2, they say calculate the potential difference across the three resistors. You know this one is going to be an easy one. So one thing I need you to tell me, what will be the current on the three resistor? What will be the current equals to?
1.5.
Exactly. Whatever current that we have here is the current that will be reading by that 3. So here on the 3 ohm, the current is 1.5. Then we can, what? This is the total current. This is the IT. This is your total current 1. The 3, this resistor is going to read what? The resistor is going to read the total current. 100%. So we are saying that the 3 resistor is in series with what? It is in series with the parallel network. So the same total current was going to flow through that 3. Let's apply Newton's law to answer 8.1.2. So Newton's, not Newton's law, Ohm's law. So V is equals to current times the resistance. I'm just going to do the substitution. 1.5 multiplied by that 3. Then you put that on the calculator, which we get 4.5 volts.
Yeah.
So this is your V. Your answer is 4.5. Are you happy with that one?
I am, yes.
Then there comes the question, hence, means that use the answer that you got to calculate the potential difference across each cell in the circuit. Oh, please. Remember, when I look at this, let's look at the V parallel. Ne? Can you see that the parallel voltage, it will be, the V parallel is going to be 6V. Do you agree with me on that?
Yes.
Right. Then if the V parallel is 6, what will be the V total, the voltage of the battery? The voltage of the battery, we're going to take the voltage that will be reading by that 3 ohm, and then we add the V parallel. That will be the total voltage. So we're going to take the 4.5, we add that to the 6. Therefore, the answer that you get, which is 10.5, this is the V of the battery. You understand?
Yeah.
Okay. But now, the question does not need the voltage of the battery. They want the potential difference across in each cell in the circuit. Do you know what we need to do next?
Divide by 2?
Exactly. Wow. Get out of here. You don't need my help, Wenaman. Eh? Because, you know, I was waiting and waiting for you to say we divide by 3. Because, you know, most of the time, learners, they count how many resistors we have. R1, R2, R3. Then since we have, what is this? 3 of them. They'll say we divide by 3, which is not true. So this, one thing that we need to understand is that one thing that we need to make sure that we understand is that the battery consists of what? 2 cells, okay, in series. So these 2 that are connected in parallel, we count it as 1 cell. So they will read the same voltage. Then is the first cell, then the second cell, it will be the one for the 3 ohm. So to find this, the potential across each cell, we're going to take that 10.5 divided by 2. So even if you want to write that in writing, you can say, you can definitely write this in this way and say, the V of the battery is equals to the V of the cell, which is the first one, plus the V of the cell, which is the second one. So then this will be 10.5, which is what we just calculated. This is 2 VC. So divide both sides by 2. Therefore, your V or for each cell will be 10.5 divided by 2. What is that on your calculator? What do you get?
2 seconds. 5.25.
5.25. So this will be volts.
Yeah.
Right. Right. This one is how many marks? 4 marks.
Mm-hmm.
Okay, 8.1.4, they want us to, okay, they want us to calculate the amount of charge. Can you please give me a second?
Okay.
Okay, so now they say calculate the amount of charge flowing through the 12 resistor in 10 minutes. Okay, so what I'm going to do is that when they say in 10 minutes, I'm gonna say I have R and then I have delta T, the time, delta T. So
Yeah.
they want us to find the amount of charge, that's Q. You go to your formula, you find the formula that has Q, maybe also T. And if you find the formula, you'll definitely see that the formula that we need to use is Q is equals to the current times the time. So this tells you that we need to first find the current that will be reading by that 12 resistor. Are you with me on that?
Yeah.
Okay, let's work on that. Let's work on finding the current. The 12 resistor, it's in parallel circuit, and if it's in parallel circuit, it will read the same voltage of that 6V. So we can definitely use that and apply Ohm's law to find the current for the 12. So this will be V over R. So the current for that 12 resistor, it will be the voltage, which is 6 over the 12. Then this is 6 goes into 6 one times, 6 goes into 12 two times, which gives us 1 over 2, which is just 0.5 amperes. So this is the current for the 12. So now that you have the current, you need to do the substitution on this formula, but you need to pay attention because the time is given in what? In minutes. We should convert the time in what? The time in second.
Yeah.
So to convert the time in second, 10 minutes, we know that 1 minute is equal to 60 seconds. So 10 times 60. Okay, I'm sorry. So then from there, what will be your T?
600.
600 seconds. Then you just have to go back. These questions are very easy, man. You just have to go back to that question and substitute from this formula here. From the formula, we're going to substitute to find the charge. We're going to calculate the charge by doing the correct substitution. So this will be Q, it's equals to the current times T, and we said the current is 0.5. This is multiplied by the time, which is 600 seconds. Therefore, we get the charge to be half of 600, that's 300 coulombs. So that's your charge.
Okay. Yeah.
Are you happy with that?
I am, yes.
Okay, so now they say on 8.1.5, switch S is now closed. Write down the reading on V1. Switch S is now closed. What will be the reading on V1? What do you think will be the reading on V1 if switch S is closed?
6 volts.
It's going to be?
6 volts?
Why is it 6 volts? Remember, when switch S is closed, it's going to provide a wire with a needleable resistance in parallel with that 6 and the 12. So this is going to create what? A short circuit across the parallel network. Therefore, the potential difference across the short circuit is 0. Since the 6 resistor is connected across the same 2 points as the shortcut, the voltage across it becomes 0 volts.
Okay.
You understand that, or you want me to explain it again?
No, I understand.
Okay, so we are saying that when switch S is closed, it's going to provide what? A wire with the needleable resistance in parallel with the 6V, right? With the 6, I mean the 6 resistor and the 12. So this will create a short circuit across that parallel network, and this will make the potential across that network to be 0. So the answer for this one is 0 volts. Don't say 0, say 0 volts, okay?
Okay.
Okay. Grade 10 learners conduct an investigation to determine the relationship between potential difference voltage at a constant temperature. They use a rheostat, which is the variable resistor, to change the currents flowing through the circuit and the particular time, and they measure the corresponding change in voltage. So the values obtained are given in the table below, the current and the voltage. If the current is 0, the voltage reading is 0. If the current is 0.3, the voltage reading is 4. So we can see that when the current increases, the voltage also increases. This is Ohm's law. V is equals to IR. As the current increase, the voltage increase, meaning that the voltage is directly proportional to what? To the current. Are you with me on that?
Yeah.
100%. So write down the name of the law being investigated in this question. What is the name and the law that is being investigated here?
Ohm's law.
It's
Ohm's law.
100%. So the name will be Ohm's law. So now I don't think you need my help in plotting the graph, but I'm just gonna tell you what you need to put on your x-axis and what you need to put on your y-axis, okay?
Yeah.
Unless if you definitely want us to plot this one, I don't mind. We can definitely plot the graph.
No, it's okay.
Yeah, but I think I do need to tell you where to put your, where should you put your current and where should you put your voltage. So now, let's add questions here. Ne? In maybe upcoming exam, they'll want you to give the dependent and independent. So tell me, what will be the, in fact, before telling me, tell me, on the x-axis, what do we put, the dependent or independent?
Dependent.
Do we put the dependent?
On the y-axis.
On the x-axis.
Oh, x-axis. Independent, sorry.
Eh?
Independent.
Wait, just give me a second. Okay, so on the x-axis, we're going to put the independent variable and the y is going to be the dependent. So now, the dependent here is the one that goes to the y variable. And then when I look at what you are given, when I look at what you are given here, the dependent is going to be your voltage.
Okay.
Because the voltage depend on the current and the current will be your independent. So when you draw your graph, you're gonna, your graph will be a straight line graph because we said as the voltage increase, the current increase. So it will be a straight line graph. You understand?
Yeah.
Line. Okay, so the next one, they say, what does the gradient of the line represent? So remember, your graph will look something like this. And they are asking you, what does the, you know, I'm not sure if I should trust you on this one. Let me just plot the graph, ne?
Okay.
Yeah, let me just plot the graph because I know that you guys always like to say, yes, we understand. And then come exam. And then this will be the current. And then this will be the voltage. So on the voltage, we'll have 0, 4, 8, 12, 16, 20, 24, then 0, 0, 0 0.3, 0 0.6, 0 0.9, 0 okay, 1.2, 1.5, and 1.8, and so on. So the 0 0.3 goes with 4. I need to connect these two guys. The 8 goes with the 0 0.6. The 12 goes with the 0 0.9. I'm just trying to plot something. I think you can understand what is going on, right?
Yeah.
Okay, so we can see that this gives us a straight line graph like that. So
Yeah.
make sure that on top you put the title of the graph,
Yeah.
where we say this is the graph. If you don't put the title, you lose a mark. The graph of voltage versus current. Okay, and then now we can see this is how the graph looks like. We can see that, and now correctly point the line of the best fit, do everything correctly. And now they say, what does the gradient of the graph represent? Do you know what is the answer for that?
No, I forgot.
But what does it represent? Because remember, you said the law that is investigated here. This is Ohm's law.
Mm-hmm.
You said it's Ohm's law, right?
Yeah.
So if it's Ohm's law, what is the Ohm's law formula? V is equals to IR. So this tells you that it represents what? The resistance. So the answer for this one, it represents the resistance.
Okay.
And that's it from me. Do you have any other question?
No, I don't. I'm good.
This was easy, né?
Yes, it was.
Should we move to the next topic? Or you still need more reinforcement on this one? I'm saying on the next lesson.
Can we just do a bit of like internal resistance, please?
Oh, yes. Okay, it's fine. On the next one, the first maybe 15 to 20 minutes we'll do internal. Then the next one will move to the next
Okay.
to the next topic, okay?
Yes. Thank you.
100%. 100%. Okay, I'll see you on the next one. Thank you very much.
Okay, thank you. See you. Bye.
Sharp.